All right, everybody, live in Mr. Shantz's basement, we have lesson 4.1. So we're starting unit 4. And it's basically very similar to what we had already started with prior to this, basically what all last unit is. So the main concept we want to take away from today is this thing right here, this y equals mx plus b. All right, and we're going to go over it, what it all means, and how to put equations of a line on a graph, or if we see a graph, how to put it in that kind of format of y equals mx plus b. So last week we were learning about rates of change and initial value of a line, and we've used a table of values, we've done a graph, we've also looked at 2 different points to get slope. So in this unit we're going to be using all those pieces of information that we've already kind of figured out last time and putting them into an equation. So just remember that when we are talking about initial value, again, it's the same thing as the y-intercept. All right, so that is, again, where the line hits the y-axis. Hits or meets the y-axis.
So the start?
Yeah, but it might not be the start. For example, in this graph that we have to the right here, like the start you might say is there, but the actual like y-intercept is that right there. Right? So that's our y-intercept.
-2.
Exactly. Very good. So that's the y-intercept. That's our initial value. All right, it's not at the bottom. Okay, so look at this graph here, and so we said y-intercept is -2. What about the slope? Anyone want to help me with that? If you eyeball it, what's the slope?
Wait, do you want like the like the coordinate things?
Well, like the value for m, right? Because the slope is going to be our rise over run.
Wouldn't it be like 4/2?
Yeah, you can do that for sure. Because the 4, if we did our drawing, if you were to draw it out, or if we just by looking at the boxes, right, we could see that our rise is +4 and +2. Now, some of you might have said, wait a minute, why is he going those particular points? We could have gone like this as well. We could have gone right there, and it said that's +2 and this is +1. Or you could have gone like here and you could, there's a lot of options because we have a lot of convenient points. In any case, it all works out to the same thing because we could have done, if we did 4/2, right? 4 divided by 2 is just 2. Or if we had done 2/1, we also get 2. It's the same thing. So either way, slope is equal to 2. All right, so we found the y-intercept, we found slope, and that's, again, using the skills that we had from the last term. Our last unit. So this time they have a common format that they fit in here. So if we write the equation of any linear relationship, right, an equation of a line, and it could be, so again, equation of a line could be applied to like a cell phone plan. It could be a gym member, anything that you can that has a rate of change that's constant. So if the rate of change is constant, like if a car is accelerating at, or sorry, the car is driving at a steady rate of 50 kilometers an hour, it's going to go 50 kilometers, then 100 kilometers, and 150 kilometers. So the point is it's a steady rate. So anything that's linear has a constant rate, right? So a linear equation has to have a constant rate of change. So they have the common form of this. So in this graph above, you get the equation. Like if, and these, each letter has a little part. So the m value, m is our slope, as we've already discussed. And b is the initial value, or the y-intercept. So if that's true, based on the equation that we had above, if we had a slope that's 2 and a y-intercept that was -2, our equation looks like this. Y equals 2x minus 2. Okay, so that's based on this and that. So all I'm doing is, even though it says plus b, right, it would be like y equals, and then we just substitute in the values for those letters. And x and y are placeholders because what they're actually doing is just adding their coordinates along the line. So if we were to multiply this out, it looks like this, which is why I wrote this here, like that. All right, so let's look at a couple different things here. So let's see if it works. So we can pick for any value of x and use the equation to find the y value. So the point of the x and y is that they are placeholders for any coordinates. They represent the placeholder for any. I'll just write this out really quickly here. So this and here. All right, so it looks like this, the xy. So let's do a couple examples just to kind of clarify it. So if we're given a value of x, so we're going to go y equals 2, and we're going to put the value in for 3, where the x is. So I'm going to substitute that in. Substitute in the value where the x was in the equation. And we got y equals 6 minus 2, y equals 4. All right? So therefore, the coordinate 3, 4 should be on the line. And let's check. All right, so let's look up at our graph and let's check if that coordinate is up on there. So if we go around and we check it, so we're looking for 3, 4. So I go over to 3, and I go up 4. There it is. Okay, it's there. All right, so this coordinate is there. So basically, if we're given any value of x or y, we can find the other value. So if I'm given an x value, I can find the corresponding y value. Let's try it again. So y equals 2. All right, so when x is negative 2, I get negative 4 minus 2, and y equals negative 6. All right, so therefore, it should be negative 2 and negative 6. Let's go up and look. Negative 2, negative 6, is that on there? There it is. All right, so it's there again. And we'll do the last one. And this one's kind of significant because a lot of times we'll let x equal to 0. And the reason why is, I'm going to write out the original equation for a second.
Isn't it like 2 times 0 would be 0, so then it would just y equals negative 2?
Exactly, that's exactly right. Yeah, exactly. So this, all it's doing is it's highlighting this last value, right? Exactly what you just said, is that it gives us the initial value, or the y-intercept. So we just end up with y is equal to negative 2. Which again, Like we know that that's on there because the coordinate, that was our first coordinate that we pulled out, was our initial value. So anytime you use x equals 0, we do this a lot in equations, and you're going to use it a lot even later on when you take other math courses. Often, if you basically, anytime you substitute in the value of 0 in for x, it's going to tell you the y-intercept. So you can always find a coordinate or a point, or you can find that y-intercept by doing that. And likewise, you could do the opposite. You could substitute in 0 for where y is, and then you could solve for x, and it'll tell you the x-intercept. It'll tell you where the line crosses the x-axis, if it does at all. All right, so it's a way of finding intercepts is by substituting zeros in. So zeros is like a superpower in math when you're graphing things, because it tells you something you know about that graph. It makes an easy point that you can put on the graph. So let's try a couple by looking at this here. So the first thing we're going to do is identify the y-intercept. Anyone want to help me out? What's the y-intercept on this first graph?
Is it 3?
Yes, very good. Yes. All right, so I'm going to put the letter B. The letter B means the y-intercept. So B is equal to 3. Now we have to do the slightly harder part, which is finding the slope. How can or anyone have an idea for the slope?
Is it rising 2 running 3? Or negative? Right, like negatively rising and then running 3?
So if it rises, or if it goes down 2, right? Can we use that? Does that work?
Yeah. Yeah.
Okay, this, I know what this is, but what is this? What's that one?
Oh, that's like running, like not even like halfway.
Exactly, because it doesn't, we don't know though, right? The point is we don't know what that is. So we can't use it. We can't use this one. What we can do is we can go all the way down to there. So if we went all the way down to here, then we're going down 3, right? And then if we went over this way, we do our run.
That'd be 6? Or wait, no, that'd be 4. Sorry,
yeah,
4.
that one's 4. So this one, and we know it's precisely 4. That's the point. If we want precise numbers, so we know that that's 4. So that's our run, right? And here's our rise. And again, I could have used this term as well. I could have said delta y and delta x. And so I get my slope is equal to rise over run, or delta y over delta x. Doesn't really matter either way. All right, so then I put negative 3 over 4. All right, I've gotten one part of it. And then I already had this part there, b equals 3. So there's the two parts of the information. So my equation looks like this. Y equals negative 3 over 4 x plus 3. Okay? And we'll do the next one together, and I want you to try, and you're going to tell me what the equation is this time. So again, let's start up this one. What is the y-intercept on this graph right here, on the second one right here? It's the y-intercept.
0?
Yeah, good. So I can say that the b value is 0, right? Because we're doing, again, we're doing it in that form of y equals mx plus b, like that. Okay, so we have b is equal to 0. Next we have to do the slope. So let's look at the slope. What's the slope of this graph?
Is it 1 over 5?
Very good. 1 over 5. So we got plus 1 plus 5. So slope is equal to rise over run. It's equal to 1 over 5. All right, so what's the equation going to be of this, right? What's the equation going to be? Anyone have a thought on that one? Remember, it follows in. We're basically filling in for M and B. So X stays there. We just need to fill in this spot there and this spot there.
So it would be 1 over 5. And then it would be like, no, it would just be like that, because then you wouldn't add the 0.
Yeah, you could put plus 0, or you could, it doesn't really matter, or you could just write it as y equals 1 over 5 x. Right? So most math, like someone, when we do math or a computer looks at it, it won't put on that 0 because 0's like it's just adding you extra work. It doesn't do anything for you, right? So all we end up with is that equation. So y equals 1 over 5x. So you don't have to put the 0. All right, let's do some more examples. So what about if we already know the equation of the line? So if that was going from looking at a graph and making the equation line, what about doing the opposite? So this time I'm going to give you the equation, which is right there.
Would it like start at -1 and then it would rise to run 3?
Exactly. That's what you have to do, is you have to start with your initial value each time. Like start with the y-intercept. So we place the y-intercept on there first, right? So if our y-intercept is this, so b equals -1, so I'm going to put that point on there first, all right? So that point's on there first. So then we use the slope, which was this part right here, which we know is the rise and the run. So if the rise is 2, so I'm going to go up 2, and then I run 3. So I know that this point is there. Now, and we can keep doing that. If we want to put additional points on there, we could just keep going like this, up 2 over 3, and then we end up with a point like right there as well. So it kind of continues on and on. And we could have gone backwards as well. Like if we started further to the left, we could just go, you know, down to over 3, like, and then you get that point there. So the line continues. But basically, all you really need are 2 points. And all you can do after you have 2 points, you just connect those 2 points, and then you'll see it just connects all the way along. So our line is only really necessary to do 2 points. We do the initial value point, and then we do slope from that, and we get a line that looks like this. And it goes in both directions continuously. So I'm putting those little arrows on there. And I'll label it. I'll finish off by labeling it going y equals 2/3 x minus 1. All right, so I added the third point on there, and you could check it, and you just basically continue on with the slope. All right, so again, you don't need to do that. Most of the time, you'll probably just put 2 points on and then connect it with the line. All right, so let's add a couple more lines on just to make sure we got the concept. So let's look at the other ones that we're given. We're given this one here. Same thing. Find the initial value. So if we look at it,
So it would be starting at 1.
yep.
And then it would
What's the
so
slope?
it would go down, I guess, because it's -3, and then it would run 1.
Yeah, just like that. -3 over 1. It's the same thing as -3. So in this case here, again, that's your rise. Very good. You're right on the money. So if you have a whole number like this one here, it just basically means it's over 1. So let's put that initial point on there. There's our initial value. B equals 1. And we go down 3 and over 1. And we get this point there. And so we have 2 points. So I'll show you the example again. I'll just take my ruler out and we'll just graph just using the 2 points that we have there. And as I said before, it's continuous, so I'm going to put the arrow on either side. All right, so that's the second one. Now let's do another one. This time we have this formula right here. So I'm going to write down B and M. What are the values for M and B?
B is 2.
Okay,
And then M is 1 over 5.
great. And we can graph that pretty fast. Let's do it just very quickly. So there's our initial value, and it was 1 over 5. So we're going to go up 1, and then over 5. 1, 2, 3, 4, 5. And there's our 2 points. And we pull out our trusty electronic ruler. There we go. All right. We'll leave that last one. You guys can try that one if you want. Now we could do an equation from a table of values as well. So if we did an equation there from a graph, right, and we also used an equation and put it on the graph, what about if we're given a table of values? So we need to find the y-intercept on the table of values and then find the slope and then put it into an equation. So let's look at the, and we're going to also say whether it's partial or direct variation. So let's look at this first. Who can help me with this first question? I need to know the y-intercept.
B would be $12.
Very good.
And then you would just like minus 16.50 with 12.
Great. And I get this.
Which is 4.5. And then you would do the same on the other side. Which is just, I think it's 1, yeah.
Perfect. So there's our delta y, and here's our delta x. So our slope is equal to delta y over delta x. So we have 4.5 over 1, which is just 4.5.
And that is partial.
All right, and why is it partial?
Because the start is 12, like $12.
Great, perfect. So, and we've got all the values then. So we have a rate of change, which is 4.5. And we had a b value. So if that's our 2 things there, we need to put it in an equation. So if we state the equation, it's y equals something x, and we'll put it all together.
Wait, would it be y equals 4.5 over, well, you don't have to add the over 1, but, and then it would just be plus 12?
Exactly, that's it. That's the answer. All right, very good. Let's try the next one. Same idea. So is it, what's the b value? What's the initial value?
0.
Perfect. Okay, so we have 0. And we'll do the rate of change. So I got my delta x, which is 100, and then my delta y is equal to 9.8 minus 0, which is just 9.8. So my slope being delta y divided by delta x is equal to 9.8 divided by 100. And you know what? You could get a decimal for this. Like you're just going to get, what is that? 0.0, 0, yeah, it's 0.098, I'm assuming. Yes. But I'm just going to leave it as a fraction. And here's the question. Is it partial or direct variation?
Direct.
Perfect. Why is it direct?
Because there's a 0. The y is a 0 when the x is 0.
Exactly. You guys are all so smart. And so our equation would be what?
Would it be y equals 9.8 over 100 x?
Exactly like that. Perfect. All right. So now we've done a graph, we've done a table of values, and let's do the last part. So we're going to look at a word problem. So it's the same thing. We're trying to find the initial value, and we're trying to find the rate of change or the slope, and then we're going to put it into an equation. So let's look at the first situation. All right, so the cost for a talk-only cell phone plan is $0.25 per minute, or sorry, like basically a quarter per minute. Now, is it partial or direct?
Is it partial, sorry?
It is not partial. And the reason why it's not partial is because there's no initial cost.
Oh yeah, because like it starts at 0, and then when you're not talking, it's just 0.
Exactly.
Right?
Yep, exactly. So there's no initial cost. So our B value then is 0. What about the rate of change?
Is it 1 over 0.25?
You could use a fraction if you wanted to. Or you could just go like this, 0.25.
Just 2.5.
Or 1 over 4. So your equation would be, like in this case here, cost is equal to, if C is for cost, C equals cost. Right, and it's per minute. I'm going to call this T. All right. So cost is equal to 0.25 T. Or we could write this as cost is equal to 1 over 4 T. Either way, both of these are correct. And is direct because there's no initial cost. All right, let's look at a different example here. Here we have a text and talk cell phone plan. It's $10 per month plus 10 cents per minute. Partial or direct? What do you think? The question is, so is there an initial value? That's the first thing we have to think about.
Would it be direct? Because like, if you had 0 months, it would be 0.
You have the right idea for sure, but it's gonna, even if you had 0 months, you have to pay $10. It starts at $10 no matter what.
Oh, okay.
So that there is an initial cost of the $10. So it's going to be partial. The only way, like with a cell phone plan here, that you're going to see it if there's no initial cost. So either way, like if you had this cell phone plan before the month even started, you'd have to pay the $10 right off the bat, right? Basically.
Okay.
And then, so that's the the only way that we can actually graph this properly is if we charge the $10 initially right off the bat. So it's going to be partial because we have a b value, and then the rate of change is that, which we could write as a fraction as that. So in this case here, our cost would be equal to plus 10. And again, you could have said it as a fraction, 1 over 10. All right, so either one of those functions or either one of those equations, we'd be able to graph. So we could now insert a value for t. Like we could say, what if we did 30 minutes, right? And you could figure out how much that would cost by substituting the 30 in for t. All right, let's look at a different one here. We'll make this the last one, I think. So Jocelyn works full-time selling newspaper ads. She is paid $32 per day plus $8 for every ad she sells. So again, look for an initial value and look for a rate of change if there is one of either one. What do you think?
Would the initial value be 32?
Yes, it is. And that means the $8 is our rate of change. So because there's an initial value, it's partial, right? So we could say that if we put it in y equals x mx plus b form, we'd say y is equal to 8x plus 32. And that equation would give us how much money Jocelyn would make. We could figure out for any amount of hours if x is the amount of hours, right? I'll leave the last one for you guys to try out if you want to do that one. The rest is homework for you. All right, same thing. So we have graphs. We have a couple equations here, figure out whether direct or partial. And in any case, it's just building off what we did last time, our last unit. So the priority, though, will be that unit test. I think it's like 8 questions. I will be checking it to make sure that it actually is marking it correctly. So don't worry, whatever your mark is initially. If it's marking it wrong, don't stress out about it. You can send me an email, but know that I will be checking it. All right, everyone?